ever look forward to math and Mondays, but here we are. It's both. It's Math Monday. Okay, so on today's Math Monday, I want to talk more about interest rates and how they accumulate. So if you remember from my last video, I gave you this equation. A is equal to P times 1 plus I to the power of N. What does that all mean again? A is the amount of money that's accumulated after you invest. P is the principal amount that you put into the bank account or into the investment to accumulate interest. I is the interest rate, and N is the number of compounding periods. Now remember, that depends on how much we're compounding. So if it's semi-annually, that means twice a year. So in 1 year, there's actually 2 compounding periods. Okay, let's look over a really specific example because I wanted to get us a really specific special number. So say you are investing $1 at 100% interest rate annually. That would never happen. You're never going to get 100% interest rate. But what I really want to talk about is it better to invest more frequently with the lower interest rate or less frequency with a higher interest rate? So let's look at that today. So say this 100% interest rate was being compounded annually. Remember, 100% as a decimal, because we have to divide it by 100, that just gets us 1 or 1.0, but I'll just be using 1 from now on. If we're compounding that annually, which just means once in 1 year, the amount we get at the end of the year is going to equal to $1 times 1 plus 1 to the power of 1. Because the interest rate is 1, the number of times it's compounded a year is 1. What do we get? 1 plus 1 is 2. It's 1 times 2 to the power of 1. That's just $2. So you're completely doubling what you invested at the beginning of the year, which, don't get me wrong, is an amazing interest rate. But I'm using these really simple numbers here because I want to know, is it better to actually compound semi-annually? Okay, so if we're compounding semi-annually, we'll still do the 100% interest rate over the year, but we'll do 50% after 6 months and then another 50% after that next 6 months. And that's what it means to do semi-annually. So we'll get the amount that we earn semi-annually by using the formula A is equal to 1 plus, and we put 1 over 2, right? Because we're compounding that twice, so you have to divide the interest rate by 2, and that's to the power of 2 because there's 2 compounding periods now. We get 1 times 1.5 squared, and that actually gets you $2.25. So what's happening is you get more money if we just compound semi-annually versus annually. So it's obviously better to compound something more often, even though the interest rate is technically smaller, because it's still adding up to 100% over the year. So I just want to see this trend and how it continues, how big it gets, if it ever levels off, if it ever starts going down again. So let's just try a few other ones. Quarterly, remember from last week, that meant you're compounding 4 times a year, so we have to divide the interest rate by 4. So we have $1 times 1 plus 1/4 to the power of 4. And that gets us $2.44. Ooh, we keep going up, and there's big jumps. That one's not quite as big of a jump, but it's still pretty darn good. Okay, what's next? Let's try monthly. That means it's going to be compounded 12 times a year, but we need to take the interest rate, in this case 1 divided by 12. So we get 1 times 1 plus 1/12 to the power of 12, because we're compounding it 12 times in 1 year. What do we get? $2.61. That's pretty fantastic. So that's still a good jump from the last one. That's a whole extra 15 cents. And we only invested $1. So that's a pretty big deal. Again, I want to keep going and see how big this can get. Let's go to weekly. So that's 52 times a year. So that would be 1 times 1 plus 1 over 52 to the power of 52. What do we get? $2.69. It's still going up. Not as much, but it's still going up. So let's see if it levels off. We could do bi-weekly, but I'm going to skip right to daily. I really just want to see what's happening with this. So if this $1 investment is being compounded daily, that's 365 times a year. And we need to take that 100% interest rate and divide it by 365. So what happens? We get 1 times 1 plus 1 365th to the power of 365. If I plug that into my calculator, I get $2.71. So you see the jumps are getting smaller and smaller, but at this point it's still going up. So let's go to something that would never happen, but let's just do this theoretically because I really want to see how big does this get. So let's say we're compounding it hourly. How many hours are in a year? 8,760. What, is that not common sense? Is that not something you just know? Don't worry, it's actually not something I just know either. I totally had to calculate that. So if we are compounding this hourly, we take $1, we multiply it by 1 plus 1 over 8,760, all to the power of 8,760. I plugged that into my calculator. I got 2.718, which rounds up to $2.72. But I had to keep that 1 in there just for a minute because it shows you it's still going up, but now it's starting to go up really, really slowly. And that's a pretty big jump from 365 to 8,760. So we can assume that it kind of levels off here. What you don't realize is that I've come up with a really interesting pattern here, and this is actually a really important number. So the pattern, if you notice, every single time we're taking 1 and we're multiplying it by 1 plus 1 over, we'll call it the number n, and then we're taking that to the power of n. So that's the general formula of what we've been doing every single time. And what I'm really asking here is what happens as n gets really, really, really large. So what happens as we invest this semi-hourly? So that's twice an hour, every half hour. What happens when we invest every minute, every second, every millisecond? Obviously, this is completely theoretical at this point because no investment would actually compound that often. But this is a theoretical question that a mathematician named Euler asked. If something is being continually compounded, how big does it get? Because it does actually just keep getting bigger. So what that is that's actually the start of calculus. We call that a limit. So if I want to know what happens as n gets really, 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 really big, I take the limit of 1 times 1 plus 1 over n to the power of n as n approaches infinity. Obviously, n can never actually reach infinity because infinity is the biggest thing that we can think of. And once you think you've gotten to the biggest point, you just add 1 more and you have an even bigger number. So it's really a theoretical thought. But Euler, being the brilliant mathematician he is, figured that out. He called this number E. I don't know if he named it after himself, if he was being like really, really full of himself. That's possible, but it's also possible that he was like, oh, he discovered one number and named it A, and the next number and named it B, and so on. So this could also just have happened to be E, and then also happened to be his most famous number that he discovered. What this number is, though, is 2.718281828. See how it's lulling us into this false sense of security that we think that there's a nice pattern? After that, it just starts changing and we go to 459, and it keeps going like that without a pattern and without ending. So it is an irrational number. But this number and this theoretical situation is the basis for all of calculus. Because what is calculus other than the study of instantaneous rates of change? So if something is changing every single moment, every single second, every single millisecond, every single nanosecond, the smallest amount of time that you can think of, that's what calculus is, and that's what it studies, is instantaneous rates of change. So there you go. You just learned a little bit of calculus today, and it wasn't even that bad. You're welcome. See, now aren't you so excited for next week? I'm sorry, I just keep making math more awesome, and then you have to wait a whole week to learn more. But you don't, because you can just go look at my other videos if you've forgotten anything from those ones. If you have any questions for me, please email me at sigmaofsarah@gmail.com. But other than that, have a wonderful mathematical week. I'll see you next Monday. Bye.